So this is now our fourth module of the course, and this module deals with what we call the per unit system. And this first part, which is your lesson one, is really going to be talking about what is it, this per unit, or how is it even derived so that we get to it. So it's actually just a simple process that is supposed to assist us in computing your power system problems. And the reason it's supposed to be easier is because everything is either into a percentage form or it just becomes into a point form. And your one really should be then your highest number because your one should be equivalent to what we call 100% scenario. So therefore, you take what you would have in your power system, and remember your power system consists of voltage, it consists of amps, your current, it consists of your impedance, and it consists of power. Those things make up your power system. In this case, we take all of those elements and we really compute them to either be a percentage format or a per unit system. And in this particular chapter, we are utilizing the per unit system. So it also says that this per unit system is therefore very similar to your percentage because the difference is you would just multiply your per units by 100 and then you know that you already have got a percentage system that we are referring to. Then the ratio or the per unit value would normally equal to whatever is the actual value that you have or you are given in your system, and then you divide by a base. So I have to give you a base value, or you have to decide on a base value, which is going to be a value that is common on your system or the largest value that you have on your system on that item. It will be clearer as we go along on the chapter. So what I want us to note now is these two items, GB and NB, because these are you are going to use them throughout your calculations. So GB stands for your given base, which is your actual value that you would have had in your system. And then NB is told to be the new base, which is the base value that we must utilize in order to convert everything that we have into the new per unit base or new per unit value. So you will have noticed then from the previous slide that I put in that I didn't take everything that was on your notes. You need to go on your notes for studying of the formulas. I just wanted to give you what that GB and that NB stands for. Then those actual values, where are they referenced? So those actual values will be your equipment rating for your voltage, your amps, your ohms, and your kVA, which is your apparent power. So in other words, if you have a transformer, you know that the transformer will be 66 to 11 kV and it will be maybe a 10 MVA, and you can be able to either calculate or get given the current that's flowing on either side of that transformer. And they actually give you also the impedance of the transformer. And so if it was a generator, you would have the same. And if it was a line, you would have the same. In your line, you would be given your impedance into ohms, and then you can be able to transfer that because you should be able to have what the voltage of that line is going to be. Then we talk about when we're referring to the new base or the base that needs to be utilized, then it gets determined by selecting a few things. So it's either going to be your S, which is your apparent power, or it's going to be your voltage that we're utilizing as your base, or sometimes we use the combination of the two for all our calculations. So for your S or apparent power, that new base value, you would utilize it into your entire system when you are doing your calculations. However, your voltage that you are given as your base voltage that you must use for your calculations will not necessarily always be the same throughout your system. And why is that? Because we know from generation all the way to distribution, our voltage is changing all the time. So, for example, at generation, in most cases, you have got your voltages at your transformer sitting at 13.8 kV. Then your transmission, you would usually have it, let's say, at 132 kV or at 66 kV. And then in your distribution voltage, you could have it at 11 or 33 kV. So similarly then, your base voltage would change, and it would change because it would go according to the transformer that you have in the system and what those voltages are in the transformer on your HV and your LV side, and then you utilize that voltage as your base on that side of the transformer. So if you've got a line on the 66 kV side of your transformer, you will use the 66 kV as your base voltage for that line. And then if you have a line for the same network on the 11 kV side of that transformer, then you would utilize 11 kV as your base voltage, okay? Because the line is on the 11 kV side. But when I ask a question as the examiner, I may have just said to you, utilize 66 kV as your base voltage. So it's for you to then know that that base voltage might not necessarily be throughout my system, but it will change according to where I am in the system and what my transformer is telling me. Then these are the formulas that you guys know. For example, you know that your impedance using Ohm's law is equal to your voltage over your current. And then in the slide that I didn't show here, they told us that for your impedance per unit, Z per unit, is actually the same as your actual impedance multiplied by your base current that you have in the system divided by your voltage base. And therefore, if I take that one and the fact that I know that my current base is the same as my S base, which is my apparent power, divided by my Z base, then I can substitute and say that it gives me a Z base value that is going to be V squared over S base. And what you need to know furthermore, which is the last formula on the slide, is that then if this is the case, my Z per unit, and you specially use these on your lines, will then be as same as saying that it is Z actual, which is the impedance that you are given on your system, and I multiply that by my S base. Remember, it's the same throughout your system once you've been given or you have determined it, divided by my V base line squared. So you must remember it's a line to line voltage and you need to square it, okay? And you must remember also that that voltage changes on your system according to which side of the transformer you are at and what that voltage on that side of the transformer says you must utilize. So why do we want to utilize the per unit system? Well, firstly, your parameters that you have on your network, be it generator, line, transformers, your load, motors, whatever the case is, we have a narrow range of your parameters that you usually have. And therefore, it kind of makes this inaccurate when we need to do a proximity of what those values are going to be. So changing it to per unit is going to give us a defined value that we are able to utilize for that particular element. And then you've got what we call ideal transformer scenarios. So when we utilize this per unit system, we eliminate those because we're really wanting to look at what does that impedance of the transformer talk about, and then we change that into our per unit system for us to work with. Then you've got your voltage. Because your voltage is based on your transformer zone, either on your HV or your MV side of your transformer, and we're always utilizing that voltage based on where we are of that transformer side, then it means that we are always almost close to unity. If your line is exactly the same as the transformer voltage, in other words, it's an 11 kV line and your transformer was stepping down to 11 kV, then obviously your base voltage would be a unity because it would be 1. But if, for example, on your generator, as we like having a generation, your generators would usually be about either 13.2 kV or 13.8 kV. But your transformers are standardized at 11 kV, stepping it up to another voltage. So therefore, there it would be close to unity, but not exactly at unity. Why? Because your generator is not exactly at the transformer voltage. Although now you are still going to utilize that 11 kV as your base because that's the side of the transformer you are at, but it means you are not going to have a unity situation because your generator is not exactly at 11 kV. But where it actually is 11 kV as well, generator yako, then you have a unity system in there. So we always utilize the per unit or sometimes the percentage method for us to do our calculations and making them simpler than when we use our actual voltages, currents, or amperes and ohms in your impedances. And what is the disadvantage of using this per unit system? Well, the system modifies components' equivalent circuits. So our equivalent circuits are going to change because we're changing everything in it into a per unit system. So sometimes we are going to have phase shifts that are going to happen or that are going to be present. And then if we don't unscale those, that they are going to totally disappear into the system, and then our per unit circuit is going to be inaccurate and not represent what the actual circuit was like. Then some of the equations as well that hold in the unscaled case get modified when we scale into the per unit. So you are going to have the square roots of 3's if you're talking about line voltages compared to phase voltages. We're going to have the factors of 3. Either we add or we remove them when you're talking about three-phase power. So in the case of our three-phase system, we are always going to use our line-to-line voltage. But your power is always going to be on a per phase basis, okay? So if you're given then the voltage, which is a phase voltage, then we must know we need to do a multiplication of that phase voltage by the root of 3 so that we can get to our line voltage. So we know then we're going to have your Z per unit, which coming from the previous slides as Z actual times my I rated over V rated. And if my I phase is the same as my line current phase is the same as my line current, then it means that it can become my S base and I divide by that root 3 VL. And then my V phase simply being the VL over the square root of 3, which would then at the end of the day give me what I showed you in that previous slide at the bottom of it, where we had the Z per unit becomes our Z actual multiplied by our S base and we divide by our V base squared, and that is your line voltage. And then if it had to take this equation and you substitute it into our other equation, which was equation 5 on the previous slide, you would simply say that your impedance new base was equal to your V squared new base, which is line, and I divide by my S new base. So although I did not say in the previous one, your equation 8, that S base is your new base, it obviously is your new base because it's the base that you are utilizing in order to convert into your per unit system. So when we choose our base, if you are asked to choose your own base, or I don't give you a base in the question, you need to know that the base that you're trying to select should be one where you are going to yield a per unit value that is approximately going to be unity, which means that it should be a 1 as your maximum value. So what am I saying? If I don't give you a base value to work with, especially on your power, because this is where it mostly gets affected, then what it means is that if you have a generator that is going to be, let's say, 50 MVA, a transformer that is going to be, let's say, 30 MVA, and you've got a motor that is 25 MVA. So of those three, you must go take the largest one. So that would be the 50 MVA, and you can utilize that. So that's the first rule. Or the second rule is you can go and either combine those bases and then utilize that as your base value. But then you would have your values being too fractionalized. So you at least want to have one of them being equal to 1, which then comes to the third point that says out of the 50 or the 20 or the 30 MVA, you can use any of the three that appears on your system, because then you are going to have a per unit that is going to give you 1. But for me, I prefer to utilize the largest one so that I make sure that all of my other ones are below 1 and only there is one that is going to be sitting at the unity value. So to be on the safe side, if you're not given one, look at your network and then choose the base value that is the highest out of the components that you have. If you choose one that is not highest and you've already gone way down on your calculations, don't go back and change it. Leave it like that. As long as it was one that you already had in the system, it's fine. Because as long as you utilize it as well throughout your question, then you will still come to the same answer that another person would have used, another base will come to. Okay. Then your great advantage in making your per unit calculation is that you realize your selection of different bases for the system. So it makes them much easier for you. And your per unit values must be calculated using the same base value. You don't change it unless it was obviously your voltage, which changes only according to the transformer zone. So again, I highlight here that your given base, you must remember, is the base at which your system is at, compared to your new base, which is the base I am saying you need to calculate using so that you can get to the new Z per unit. Now, in most of these questions, or maybe not in this chapter, but in the next chapter, when we do these calculations, we've picked up something that makes the people to not even go and utilize these formulas. For your equipment, your generator or your transformer or your motor, you will have an impedance of that equipment. And sometimes that impedance could be in ohms or it could be in per unit. You still need to change it, even if it wasn't per unit, into a new per unit value then. And you do that by utilizing the formulas that would have changed it into a per unit. And we are going to see, hopefully, some of those examples as we go further into our So these formulas, guys, I need you to learn them, know them, live them, memorize them. They must be with you because I don't give them out in a test or an exam scenario. So you can see with what I was saying on the previous slide now, here you have an equipment that is already at per unit. Okay, so it could be a transformer, or it could be a generator, or it could be a motor, but it's already in a per unit because they've changed that impedance into a per unit. You still need to change it into a per unit new base. And this is how you would then do. You would take that per unit that they've given you and you would multiply it by your S new base over your S given base, and then you multiply it by your V given base over your V new base. And remember, your given is what you had already in the system, and your new is what you must utilize in order to change that given base of your impedance to a new Z per unit. And then you would go also and look at the other ones that you see over here. So what is different from this slide, from your previous slide, is that in your previous slide and the formulas that you had there, you were utilizing those when your Z of your equipment or your line or whatever you have in your system was in ohms. But now in this slide, your Z of those equipment already on the system is already into per unit, but you still have to change it into a new base of your per unit. So that's why these formulas are not the same. So depending on what you're given, is it ohms or is it a per unit value, you would then know which of these formulas that you need to go and apply onto your calculation.